A foreboding orchestra of tremors has been steadily intensifying beneath the tranquil vistas of Yellowstone National Park. This serene landscape, famous for its geysers, diverse wildlife, and captivating wilderness, is whispering a tale of deep geological unrest. As if acting out a thrilling yet mysterious drama, Yellowstone has recently been shaken by hundreds of earthquakes, each adding a new chapter to the park's complex geological narrative. What can these quakes tell us about the secret life of the Earth's crust, hidden beneath the idyllic panorama of Yellowstone? Let's embark on an enthralling journey beneath the surface to uncover the truth. Number 1. What's Yellowstone, and why is it special? Unfurling across the heartland of the United States, stretching its boundaries into Wyoming, Montana, and Idaho, lies Yellowstone National Park, a spectacle of nature's splendor. Covering a sprawling 2.2 million acres, the park is a haven of diverse flora and fauna, encompassing more than 60 species of mammals, including the iconic grizzly bear, wolves, and herds of bison and elk. The vast wilderness throbs with life, resonating with the symphony of untamed nature. But what truly sets Yellowstone apart is its unique geological heritage. Yellowstone isn't merely a park. It's a living, breathing testament to the dynamic forces that shape our planet. It's home to one of the world's largest active volcanic systems, simmering beneath its serene surface. It's here where Earth's crust is at its thinnest, and the underlying molten rock, or magma, bubbles closer to the surface than almost anywhere else on Earth. The park's geothermal hotspots have created a dazzling array of geysers, hot springs, mud pots, and fumaroles, including the legendary Old Faithful geyser. Its performances are punctuated by eruptions of scalding water that can reach as high as 185 feet, painting the skies with steam. With over 300 active geysers, Yellowstone boasts more of these natural wonders than anywhere else on Earth, a tribute to its remarkable geothermal energy. Yet, the real jewel in Yellowstone's geological crown is the colossal supervolcano that lies dormant beneath the park's rugged landscape. A supervolcano is a behemoth that has, in the past, erupted with a force over 1,000 times greater than a regular volcano. Yellowstone's supervolcano, which last erupted around 640,000 years ago, has since been silently slumbering. But its existence defines the park's geological character and has captivated the imagination of geoscientists and tourists alike. The evidence of the supervolcano's existence is visible in the form of the 30 by 45 mile wide Yellowstone caldera. A caldera is a massive depression formed when a volcano empties its magma chamber in an eruption, causing the ground above to collapse. This scar-like depression bears testament to the cataclysmic eruption that once shook this landscape. When the national park was established in 1872, it became the first of its kind in the world, paving the way for the global national park movement. The park's unique mix of natural beauty, abundant wildlife, and fascinating geology has made it a favorite amongst naturalists, adventurers, and geologists. It's a place where one can simultaneously marvel at the beauty of a sunset over the Lamar Valley and contemplate the tremendous forces that lie beneath our feet. Yellowstone's charm, however, extends beyond its physical wonders. The park is steeped in rich cultural history, dating back over 11,000 years. Numerous Native American tribes, including the Shoshone, Bannock, Blackfeet, and Crow, have called the region home for centuries, their lives intricately woven with the land's bounty. Their tales echo in the landscape, as historical sites scattered across the park narrate their struggles, triumphs, and deep-rooted respect for nature. Yellowstone's cultural tapestry was further enriched with the arrival of European explorers, fur trappers, and settlers in the 19th century. Their influence is still evident in the rustic charm of historic structures like the Old Faithful Inn, one of the park's architectural landmarks. The park's status as a global leader in ecosystem preservation further amplifies its significance. Its comprehensive conservation efforts aim to safeguard the delicate balance between man and nature, protecting the park's exceptional biodiversity and ensuring the survival of its geological wonders for future generations. From the fiery depths of its lurking supervolcano to the cultural narratives imprinted on its landscape, every aspect of Yellowstone National Park whispers a unique story. This amalgamation of vibrant ecosystems, dynamic geology, and cultural heritage makes Yellowstone truly special, a living microcosm of Earth's grand evolutionary saga. As we delve deeper into the mysteries of its recent seismic activity, we tread a path that intertwines human curiosity with nature's profound enigmas. Number 2. Unveiling the secrets of seismic activity. As we journey deeper into Yellowstone's subterranean enigma, we must first demystify the phenomenon of seismic activity. Earthquakes, a term that often brings visions of destruction, are, in fact, evidence of our planet's dynamic nature. They are born from the restless movements of vast tectonic plates, immense pieces of the Earth's crust that fit together like a jigsaw puzzle. As these plates interact, they produce an array of geological phenomena, including mountains, trenches, volcanoes, and of course earthquakes. Most earthquakes occur along the boundaries of these plates, where tension from their movement accumulates over time. When the stress exceeds the rock's strength, they fracture, releasing stored energy as seismic waves. These waves radiate outwards, causing the ground to shake, a phenomenon we perceive as an earthquake. However, not all earthquakes are created equal. They vary in frequency, intensity, and depth, each characteristic offering clues about the Earth's internal processes. Earthquakes are measured using the Richter scale, which quantifies their magnitude, and the modified Mercalli scale, which assesses the intensity of shaking and damage at specific locations. Seismic activity in regions like Yellowstone, far from the edges of tectonic plates, hints at unique geological processes at play. Here, the culprit is the park's infamous supervolcano, or more accurately, the hotspot that powers it. A hotspot is a plume of hot material rising from deep within the Earth's mantle. When this material reaches the surface, it creates a chain of volcanic activity. The Yellowstone hotspot, one of the most intense on the planet, is responsible for the park's extraordinary geothermal and seismic activity. Beyond the dramatic spectacle of shaking ground and swaying trees, earthquakes serve a more profound purpose. Each quake acts as a beacon, sending signals that help scientists peer into the Earth's crust, much like a doctor uses X-rays to examine the human body. These seismic signals shed light on the subsurface geological structures and processes, enabling us to piece together the planet's dynamic history. In Yellowstone, this seismic X-ray has revealed a vast magma reservoir lying beneath the park, in addition to the shallower magma chamber already known. This discovery was made possible by analyzing seismic waves from earthquakes. When these waves encounter different materials, like magma or rock, they slow down, speed up, or change direction, creating a seismic shadow that can be detected and analyzed. Despite the ominous connotations associated with earthquakes, it's important to note that seismic activity is a regular occurrence in Yellowstone. The park experiences between 700 and 3,000 earthquakes annually, most of them so weak that they go unnoticed by humans. These frequent, low-magnitude tremors are a natural product of the geothermal forces at work beneath the surface. They serve as a constant reminder of the park's simmering volatility, and are vital to maintaining the geyser's rhythmic eruptions we've come to associate with Yellowstone. Yet, there are times when Yellowstone's seismic activity transcends its usual pattern, giving rise to what is known as an earthquake swarm, a rapid-fire sequence of tremors originating from the same location. Unlike typical earthquakes, which have a noticeable main shock followed by smaller aftershocks, swarms feature many earthquakes of similar size. These intriguing phenomena often trigger speculation and concern due to their potential association with volcanic activity. And it's here, amidst this complex interplay of crustal movements, magma intrusions, and geothermal marvels, that our story takes a seismic twist. Recently, Yellowstone has been at the epicenter of an unusual flurry of tremors, an earthquake swarm that is intriguing and confounding scientists around the world. This symphony of tremors has been resonating under Yellowstone for months, making the ground beneath the park hum with an unusual rhythm. Understanding this phenomenon's true implications, however, requires us to venture beyond the surface-level spectacle and fear. Are these quakes a harbinger of an imminent volcanic eruption, or are they merely a dramatic expression of the Earth's ordinary machinations? As we grapple with these questions, we must remember that seismic swarms, though intense, are not an unprecedented occurrence in Yellowstone. The park has experienced similar episodes in the past without leading to volcanic eruptions. The job of decoding the seismic messages sent by these quakes falls on the capable shoulders of geologists and seismologists. Using an array of sophisticated tools and technologies, they are tirelessly probing this seismic swarm, attempting to unravel the enigma unfolding deep beneath Yellowstone's beautiful landscapes. It's through their dedicated efforts that we may soon uncover the hidden narratives penned by these earthquakes, lending us invaluable insights into the Earth's dynamic nature. Ultimately, every tremor is a thread in the larger tapestry of Yellowstone's geological narrative, weaving together a tale that encompasses the very birth and evolution of our planet. To comprehend this tale, we must journey further into the heart of the recent seismic swarm and its potential implications for Yellowstone, its abundant ecosystems, and the millions who call this region home. So, let's continue to unravel the seismic secrets that Yellowstone is so earnestly whispering to us. Number 3. The recent seismic swarms at Yellowstone, an unprecedented symphony of earthquakes. In recent months, a seismic concert has been steadily unfolding beneath the surface of Yellowstone National Park. It is a concert of hundreds of tremors, creating a series of earthquake swarms that have intrigued geologists and visitors alike. These swarms, a cascade of minor quakes originating from the same location over a short period, have painted a tale of unsettling activity beneath the park's serene facade. The beginning of this geological rhapsody can be traced back to the quiet depths of the park, where the restless Yellowstone hotspot simmers. In recent months, its molten plumes have been especially lively, their movements setting off a domino effect of tremors. These tremors, like a geological drum roll, have led to a crescendo of seismic activity that reverberates throughout the park. The magnitude of these quakes, while not large enough to cause significant surface damage, has been notable. Several tremors have registered magnitudes over 3 on the Richter scale, enough to occasionally rattle windows and shake the park's loose soil. Yet, it's the sheer volume and persistence of these tremors that have caught the attention of scientists and the public. What distinguishes this seismic swarm from those in the past is not just its intensity, but also its depth and location. Unlike previous swarms, which were generally spread out, the recent tremors have been concentrated around the park's largest geyser, Steamboat Geyser, and they have originated from a shallower depth. This proximity to the surface, combined with the geyser's intensified activity, has sparked curiosity and speculation. Some might question whether these tremors could signify a forthcoming eruption of the Yellowstone supervolcano. After all, these quakes are echoing from the vicinity of a sleeping giant that has unleashed cataclysmic eruptions in the past. To quell these concerns, it's crucial to remember that seismic swarms at Yellowstone are not unusual. The park has a long history of such events, most of which are driven by the movement of hydrothermal fluids or gas through the park's complex subsurface network of fractures and fissures. Importantly, earthquake swarms in volcanic areas don't necessarily signal an impending eruption. In many cases, they reflect changes in the hydrothermal system, like shifts in the groundwater level or the movement of gases beneath the surface. While these activities can lead to increased geyser eruptions or changes in hot springs and mud pots, they are often unrelated to the deeper magmatic processes associated with volcanic eruptions. The ongoing symphony of tremors beneath Yellowstone, despite its scale, has not triggered any significant changes in the subsurface magma reservoir. Geoscientists studying the swarms have found no signs of ground deformation, a key indicator of magma movement that would suggest the awakening of the dormant supervolcano. Instead, the quakes appear to be a dramatic demonstration of the park's dynamic geothermal systems, choreographed by the dance of hydrothermal fluids beneath the Earth's crust. The swarms could be the park's way of adjusting to internal pressure changes, a geological sigh of sorts, as it maintains its delicate balance. While the swarm's geological implications are yet to be fully understood, it's important to view this event as a remarkable opportunity for learning. The data derived from this unusual seismic activity is a goldmine for scientists eager to decipher the park's intricate geology. Every tremor, every shudder offers new insights into the hidden processes shaping one of the most geothermally active regions on the planet. Number 4. The potential impact, a nightmare scenario or an overhyped concern. As the whispers of Yellowstone's seismic swarm grow louder, they reverberate beyond the confines of the park, reaching millions worldwide. The nature of these tremors, especially their association with the park's dormant supervolcano, has sparked widespread fascination and concern. The potential for catastrophic destruction posed by a supervolcanic eruption is indeed mind-boggling. Yet the question remains, are these fears grounded in reality, or are they an overreaction to a natural, albeit dramatic, geological phenomenon? A supervolcanic eruption is a spectacle of nature's raw power, a cataclysmic event that can alter global climates and reshape landscapes. The Yellowstone supervolcano, one of the world's largest, has unleashed 3 such eruptions in the past 2.1 million years. Each of these events spat out over 1,000 cubic kilometers of ash and lava, burying vast regions in volcanic debris and plunging the planet into a volcanic winter. The last of these eruptions occurred approximately 640,000 years ago, giving birth to Yellowstone's current caldera, a volcanic crater measuring about 55 kilometers by 80 kilometers. If such an eruption were to occur today, the consequences would be nothing short of apocalyptic. Thick layers of ash would smother large swaths of the United States, crippling infrastructure and wreaking havoc on agriculture. The ejection of vast amounts of sulfur dioxide into the atmosphere could also lead to a drop in global temperatures, potentially triggering a mini ice age. This dystopian scenario, while terrifying, is not a foregone conclusion. The history of the Yellowstone supervolcano suggests that major eruptions are infrequent, with hundreds of thousands of years separating each event. Additionally, most volcanic activity in Yellowstone over the last few millennia has been non-explosive, characterized by the slow extrusion of lava flows within the caldera. Importantly, the scientific consensus, based on current geological understanding and monitoring data, suggests that a supervolcanic eruption at Yellowstone in the foreseeable future is extremely unlikely. While the recent earthquake swarm has resulted in an uptick in seismic activity, it hasn't triggered any significant changes in the subsurface magma reservoir or the caldera's ground deformation, key indicators of an impending eruption. In fact, analysis of these seismic events has revealed that most of them are hydrothermal in origin, related more to the park's geysers and hot springs than to the ominous supervolcano. This implies that the current seismic swarm could be a manifestation of changes in Yellowstone's hydrothermal systems, and not necessarily a harbinger of volcanic doom. Yet even as we downplay the specter of a cataclysmic eruption, we must not underestimate the park's potential for localized hazard scenarios. Yellowstone's dynamic landscape is continually molded by smaller-scale geological activities that can pose risks. These include minor volcanic eruptions, hydrothermal explosions, landslides, and of course earthquakes. While these events are unlikely to have global ramifications, they can significantly impact the park and its immediate surroundings. For instance, hydrothermal explosions, which occur when superheated water turns rapidly into steam, can create craters several meters wide. Though typically confined to the park's geyser basins, these explosions have the potential to injure unsuspecting visitors or damage infrastructure. Moreover, the park's abundant geysers and hot springs, a primary tourist attraction, are directly influenced by seismic activity. Earthquakes can alter the behavior of these features, causing some to become more active, while others may cease to erupt altogether. This was evident during the Hebgen Lake earthquake in 1959, which caused dramatic changes to many of Yellowstone's geysers and hot springs. Similarly, seismic activity can trigger landslides, posing risks to roads, trails, and structures within the park. More significantly, strong tremors could potentially initiate a landslide into Yellowstone Lake, leading to a tsunami within the lake and flooding along the shoreline. To mitigate these risks, continuous monitoring of Yellowstone's seismic and geothermal activity is imperative. The United States Geological Survey, USGS, in conjunction with Yellowstone National Park and the University of Utah, operates an extensive network of seismometers, GPS stations, and other instruments to track the park's geological behavior. This data helps scientists detect any significant changes that might precede hazardous events, enabling them to issue timely warnings. While the potential for a catastrophic supervolcanic eruption at Yellowstone remains a captivating topic, it is far from being an imminent threat. The recent seismic swarms, despite their dramatic nature, appear more likely to be a testament to the park's dynamic geothermal activity rather than a precursor to volcanic doom. As we continue to unravel the mysteries of Yellowstone's geology, it is essential to balance the thrill of scientific discovery with a responsible approach to hazard awareness and risk management. After all, understanding and respecting our planet's power is the key to living harmoniously within its vibrant, ever-changing landscapes. Number 5. The role of geoscientists and park officials, the heroes behind the scenes. Beneath the breathtaking beauty of Yellowstone National Park lies a volcanic titan and a geological puzzle that continues to baffle and intrigue scientists. This land, ever dynamic and vibrant, demands vigilant monitoring and understanding. In the heart of it all, a group of dedicated individuals stand as our protectors and translators of Yellowstone's enigmatic geology. They are the geoscientists and park officials, the unsung heroes working relentlessly behind the scenes. These geoscientists are Earth's detectives, interpreting the signs and signals emanating from Yellowstone's depths. Using cutting-edge technology and innovative methodologies, they monitor the park's seismic activity, track ground deformations, analyze gas emissions, and study changes in the behavior of geysers and hot springs. Each tremor, each puff of steam, and every minute change in the landscape becomes a clue in their ongoing investigation into the park's complex geothermal systems. Their work involves painstaking data collection and analysis. By deploying seismographs across the park, they are able to record and measure earthquakes, distinguishing between minor tremors and significant seismic events. GPS stations, meanwhile, help detect even the smallest ground movements, providing clues about subsurface magma movement. The data gathered is rigorously analyzed, then compared with historical records to discern patterns, anomalies, and potential trends. Simultaneously, these geoscientists are our educators and communicators, translating complex geologic processes into understandable terms for the public. Through regular updates, they provide clear and timely information about the park's geological activities, dispelling misconceptions and easing public concerns. They remind us that while Yellowstone's geology is active and occasionally dramatic, it is not necessarily cause for alarm. Working alongside these scientists are the park officials, guardians of Yellowstone's vast expanse. Their role in managing the park's natural resources, ensuring visitor safety, and facilitating scientific research is vital. They are on the front lines, observing firsthand the changes in Yellowstone's landscapes and relaying important information to the scientists. They implement safety measures, close trails or areas if needed, and ensure that visitors respect the park's natural features. These park officials are also crucial in the effort to educate visitors about the park's geological hazards. They regularly update the park's safety guidelines and inform visitors about areas of increased geothermal activity. By doing so, they ensure that the public can safely appreciate the wonders of Yellowstone without endangering themselves or the park's delicate ecosystems. Together, these geoscientists and park officials form a formidable team, tirelessly working to understand and protect Yellowstone. They stand as a bridge between humanity and the natural world, enabling us to coexist with and appreciate the extraordinary geology of Yellowstone National Park. Yet, their task is monumental, and it's one they cannot undertake alone. They rely on the support and cooperation of visitors, local communities, and institutions worldwide. So, as we marvel at Yellowstone's spectacular geology, let us remember and appreciate the immense effort and dedication that goes into understanding and preserving this natural wonder. We must respect their guidelines, contribute to their research when possible, and help spread accurate information about Yellowstone's geology. The task before us is to find the balance between exploring and preserving, between appreciating nature's grandeur and respecting its raw power. As we continue to navigate the fascinating geological narrative of Yellowstone National Park, We have a part to play in this grand adventure. With every tremor that shakes the park, let us endeavor to shake off our misconceptions and fears, replacing them with knowledge, respect, and a sense of responsibility towards our extraordinary planet. Together, we can contribute to the sustainable coexistence of humanity and nature, ensuring that future generations can also experience the awe-inspiring wonder of Yellowstone National Park. Indeed, the seismic symphony beneath Yellowstone is a call to action for all of us. It urges us to embrace a more informed, proactive stance towards our natural world. While the prospect of a supervolcano eruption might seem terrifying, the reality is that such an event, based on our current understanding, is highly unlikely in our lifetimes. Rather than succumb to unfounded fears, we should channel our energies into learning more about these geological phenomena and the processes that drive them. Supporting the work of geoscientists and park officials is paramount. They are our guides in this journey of understanding, providing valuable insights into Yellowstone's geothermal mysteries. As they continue to monitor and interpret the park's seismic activities, their work lays the groundwork for more effective disaster preparedness and response strategies, not just for Yellowstone, but for geologically active regions worldwide. Remember, every shudder, every tremor we feel beneath our feet is an echo of Earth's untold stories. By choosing to learn from these seismic whispers rather than fear them, we become active participants in a shared narrative of discovery. We encourage you to share this fascinating saga of Yellowstone's seismic activities, sparking conversations that inspire curiosity and respect for our planet's geological wonders. As we stand at the precipice of discovery, we invite you to join us in this journey. Share your thoughts, concerns, and reactions to these seismic occurrences. Let's foster a dialogue that helps demystify these natural phenomena and highlights the importance of scientific research and conservation efforts. Together, we can ensure that Yellowstone's majestic landscapes continue to inspire and intrigue generations to come.